Hello, this is the review for my Algebra 2 Honors class, Quiz 7.2 review. Here we go. So, target 4 is solving exponential and logarithmic equations. So here are 3 different problems for you to give it a try at. Hit pause, give them a try, come back, and learn the explanation. All right, first step is we want to add 7 to both sides. So we get 12 to the 3x plus 4 equals 20. At that point, you're like, what do? I don't know what to do. I don't know what to do either. So since we can't do anything in exponential form, we are going to turn it into logarithmic form. So we're going to have log base 12 of 20 equals 3x plus 4. Because remember, the exponent goes on the opposite side of the equal sign by itself. Here, you're like, woohoo, it looks different, but I still don't know what to do. So we're going to take this first part here, the log base 12 of 20, and we're going to do the change of base theorem. So log of 20 divided by log of 12. And still set it equal to the 3x plus 4. Log of 20 is 1.301 divided by 1.079, still setting equal to 3x plus 4. Then 1.301 divided by 1.079 is 1.206, setting equal to 3x plus 4. And then you just solve that equation. You subtract 4 to both sides. We end up with negative 2.794 is equal to 3x. Divide both sides by 3. And you get the most marvelous answer of negative 0.931. Okay, try the second 2 on your own. Come back to see if you got the correct answer. Okay, if you have the correct answers here boxed in green and then black on the second 2/3 of the sheet, then you're good to go. Continue on to the next slide. If not, here's a short explanation. For this middle one, we're going to add 5 to both sides. Then we get the 23. So we get 23 equals 3 to the 0.6x plus 1. We write it in logarithmic form. So we have log base 3 of 23 equals the exponent of 0.6x plus 1. Again, we do change of base theorem, so that all ends up being 2.855 equals 0.6x plus 1. Solve that equation to end up with x equals 3.092. And then the third equation here, we add 15 to both sides, so we get 11 to the negative 2x minus 6 equals 17. Put it in logarithmic form once again, so we have log base 11 of 17 equals negative 2x minus 6. Do change of base again, so log of 17 divided by log 11. And do all those calculations in your calculator, 1.182, and set that equal to negative 2x minus 6. Solve that equation, and you end up with negative 3.591. Okay, next type of problem is solving equations with logs on both sides. So letter A, we're going to walk through it together. Then you can try B and C. So we have the natural log of 7x minus 3 equals the natural log of 2x plus 2. Because they are both natural logs here, meaning they both have the same base of e, then our parts here are equal to one another. So 7x minus 3 equals 2x plus 22. And you just solve that equation. You subtract 2x to both sides, add 3 to both sides. We get 5x equals 25. Divide both sides by 5, and x equals 5. Yay! Give the next 2 a try, and then come back to check your answers. Okay, coming back, the one in the middle. Here in green, we have 12x minus 11 equals 3x plus 13. Solve that equation. 24 over 9 is not acceptable. Why not? Yeah, that's right. You did not simplify the fraction, so you need to simplify it to be 8/3. The third one here in blue, we set 3x minus 10 equal to 14 minus 5x. Solve the equation and you get x equals 3. And everyone in class today was like, dude, Miss Teal, what's up with that? Your answer key is wrong. Why is it no solution? It is 3. It is not 3. You need to go back and check these and plug them back in to this original part right here. You plug 3 in. 3 times 3 is 9. 9 minus 10 is negative 1. You cannot have a negative 1 in that part of a logarithm. So x equals 3 does not work, so your answer is no solution. So let's go back and check the previous ones here. Here in red, we're going to plug in the 5. 7 times 5 is 35. Minus 3 is 32. Good to go. 2 times 5 is 10. 10 plus 22 is 32, and we're good to go. They're the same. Here in the middle with the green, we have 12 times 8/3, and because you've done your fraction packet, you remember how to multiply fractions, and you get that 12 times 8/3 is 48, and then minus 11 is 37. I'm sorry. Not 48, 32. It's been a long day, what can I say? So 32 minus 11 is 21. And then over here, plugging in 8/3 times 3, again, would be 8. And then 8 plus 13 is 21. Those are both positive, and they're the same number, so we are good to go with that. You just need to remember you can't have a negative 1 there, so we need to be checking those to see if they work out as we go along. Okay, next one is solving an exponential equation when only a log is on one side of the equation. We'll do this first one together. So we have log base 5 of 2x plus 3 equals 2. Well, we can't do anything in the form that it's in right now, in the logarithmic form. So maybe if we turn it into exponential form, we can figure something out. So we have the base is 5. The exponent is squared equals 2x plus 3. So we solve that, so we get 25 equals 2x plus 3. 22 equals 2x, and x equals 11. But let's go back and check, because we learned our lesson on the last problem. We need to go back and check them. So plugging in 11, 2 times 11 is 22, plus 3 is 25, so it's positive, we're all good. And then we check, 5 squared is 25, so we are good to go with this one. Okay, try the next two on your own, come back and check your solutions. Okay, here we go in blue. We rewrite it into exponential form. So it becomes 4 to the 5th equals 7x minus 82. Then we solve the equation. We do 4 to the 5th, which is 1,024. Add 82 to both sides, so we get 1,106 equals 7x. Divide, so you end up with x equals 158. We go back and plug it in to make sure it checks out. So 7 times 158 is 1,106. Minus 82 gives us 1,024. And 4 to the 5th is 1,024. So it all checks out. Yay! We like things when they check out. Okay, here in the red, we wrote it in exponential form. 7 to the 3rd equals 2x minus 15. 7 to the 3rd is, of course, 343 equals 2x minus 15. Solve, so we get 358 equals 2x. Then divide both sides by 2, and x equals 179. Plugging it back in. 2 times 179 is 358. 358 minus 15 gives us 343. And 7 to the 3rd power is 343. So it all checks out for us. Yay! Okay, next problem is doing the same sort of thing that we did on number 1, but with an e as the base. So we have e to the 4x plus 6 equals 22. And you're like, dude, don't know what to do. We don't want to put it in log form because it has a base of e. So we're going to put it in natural log. So ln of 22 equals 4x plus 6. We type in the natural log of 22 in our calculator, and we get 3.091 equals 4x plus 6. And then we just solve the equation. We subtract 6 to both sides, we get negative 2.909 equals 4x. Divide both sides by 4. And x equals negative 7.2. Oh, sorry about that. It's negative 0.727. So negative 0.727. And that is your answer. Okay? Give B and C a try. Come back to check your solutions. Okay, here in blue, we write it into logarithmic form, in this case natural logarithmic form. And the natural log of 35 equals negative 2x plus 3. The natural log of 35 is 3.555 equals negative 2x plus 3. Solve the equation, so we end up with 0.555 equals negative 2x. Divide both sides by negative 2, and you get x equals negative 0.278. Part C, here in green, we write this in logarithmic form, so we end up with the natural log of 274 equals 5x. The natural log of 274 is 5.613 equals 5x. Divide both sides by 5, and x equals 1.123. 1.123. There we go. I think I missed a 1 the first time. You can check your answer, so you should never get this wrong on a quiz or a test. It's very simple to check your answer. You're going to take your answer. I'm going to use the blue one here as a model. You're going to plug negative 2.78 in here to the x, the original equation. Plug it in your calculator, and you should get approximately 35. You're not going to get exactly, but you're going to get really, really close to 35 in your answer. And that's a way to check it, so you should never get this wrong on your test. Okay, these a little bit more complicated. Not that bad, though. So here on the left-hand side, we have 2 logs. And on the right-hand side, we got no logs over there. So, remember, when we're adding with logarithms, what are we really doing? Naturally, we're going to multiply. So, we're going to rewrite this. So, we have log base 4 of x times x plus 6 equals 2. And that's the step a lot of us forgot in class today when we're doing this, because you forgot to then deal with the 4 in the problem. So, I would do this step first so you don't forget that step. Okay, now we're going to write it into exponential form. So we have 4 squared equals, I'm going to go ahead and distribute out this x, so we end up with x squared plus 6x. We're going to get everything to one side, preferably where the x squared is positive. So I'm going to square this 4 and move it at the same time. So I'm going to end up with 0 equals x squared plus 6x minus, I don't know what that thing is there, minus 16. Now, it's our old friend factoring. So what numbers multiply to be negative 16 and add to be positive 6? Huh? Got to think about it a little bit. 16, 1, 16, 2 and 8, 4 and 4. What combination works? Oh, yay! X plus 8, x minus 2. Then we need to solve both of those. So x plus 8 equals 0 and x minus 2 equals 0. X equals negative 8. X equals positive 2. But are we done? No, we're not, because we learned our lesson from number 2, part C. We learned our lesson. We're going to go back and we're going to check ourselves and see if they work out. So we're going to plug negative 8 up here. And right away, we plug negative 8 in. It's just an x, so it's going to stay negative 8. And again, we don't want no negative there. So negative 8 does not work. So we're going to plug in 2 and see if 2 works. 2 is pretty good there. 2 into the second x would be 2 plus 6 is 8. So we have 2 and 8. So again, since we're adding, that naturally means we multiply. So 2 times 8 is 16. So you have log base 4 of 16 equals 2. And then check it. 4 squared equals 16. So you are good to go with that one. Try the second one on your own and come back for the explanation. Okay, here we go for over here in blue. We rewrite it because addition means multiplication. So log, what's the base on that one? There's nothing little written there. Do you remember what that's called? That's the common logarithm, so it has a base of 10. So we're going to rewrite it to log. So x times x plus 3 equals 1. We're going to rewrite it into exponential form. So 10 to the first power equals, and I distributed out the x already, so x squared plus 3x. We get everything to one side, so 0 equals x squared plus 3x minus 10. It's our old fun friend factoring. And we're going to factor that out. What numbers multiply to be negative 10 and add to be positive 3? That's right, a positive 5 and a negative 2. So we put x plus 5 equal to 0 and x minus 2 equals 0. Solve both of those, so we end up with negative 5 and positive 2. We go back and we check ourselves. We're going to plug negative 5 in here to the x. Negative 5 plus 3 is negative 2. Uh-oh, no negative there. We cannot have negative 5 as an answer. We're going to plug 2 in. 2 plus 3 is 5. We're going to plug it in here, so that's just a 2. 5 times 2 is 10. So the log of 10 is 1 because 10 is our base here. So 10 to the first is 10. So we are all good, and it checks out. Now on to some word problems. The average weight, y, in kilograms of an Atlantic cod from the Gulf of Maine can be modeled by the equation y equals 0.51 times 1.46 to the x, where x is the age of the cod in years. Estimate the age of a cod that weighs 15 kilograms. So give this one a try. Come back for the solution. Okay, you should have gotten approximately 8.95 or 9 years as your answer. If you did, yay. If not, here's the explanation. We plug in the 15 for the y because y represents weight. Then we're going to solve the equation for x. So we're going to do that by first dividing by 0.51 on both sides. That's very important to do that first. Some of us in class, we're multiplying the 0.51 times the 1.46. Very, very bad. It has this x up here that says you cannot mess with that thing that I'm on top of. You've got to keep it there. It has to stay 1.46. You cannot change it. So we're going to divide both sides by 0.51. 15 divided by 0.51 is 29.41. Now that equals 1.46x. We don't know how to do anything like that in that form, so we're going to turn it into logarithmic form. So the log of base 1.46 of 29.41 equals x. Again, I cannot do that in my head, so we're going to do that as our old friend change of base theorem. So log of 29.41 divided by log of 1.46, plug it in your calculator, and you get approximately 9 years of that cod that weighs 15 kilograms. Okay, very similar one. Give this one a try and come back for the explanation. Okay, our original equation is here in green with the 5.39 pupil diameter substituted in. We're going to solve that equation. We're going to subtract both sides by 13.669. Then we're going to divide by the negative 2.1158. So we end up with 3.913 equals the natural log of a. Remembering that we can't do anything in that form, so we need to turn it into exponential form. And natural logs have a base of e. So we rewrite it as e to the 3.913 equals a, and then plug it in our calculator. We get approximately 50 years old. So when you're 50 years old, this person will have a pupil diameter of approximately 5.39 millimeters. I don't want to be the one going and measuring it, though, because that would freak me out, having someone that close to my eye. Okay, give this one a try. It's our old friend, the compounding continuously equation that we had previously in this unit. Okay, for this one, we want to find out how many years it's going to take us. If we start off with $700 and put it into an account with an annual interest of 2.75%, how long will it take us to get $2,000 in there if it's compounded continuously? So we plug the 2,000 into the y. Then we divide both sides by 700 here in blue. So we're left with 2.857 equals e to the 0.0275t. At that point, you're like, I don't know what to do from there. My variable's up in the exponent. So if you can't do it in whatever form it is, you need to translate it into the other one. So it's in exponential form. We cannot do it in exponential form, so we're going to translate it into logarithmic form. Because our base is e, we're going to do the natural log. So we have the natural log of 2.857 equals 0.0275t. And then we're going to divide both sides by 0.0275. And we get the glorious answer of it would take 38.17 years. That's a lot of time. I'm not even that old yet. And it's going to take that long to get $2,000 in our account instead of the $700. That's a long time. All right, now we've moved on to target 5. Write an exponential function y equals a b to the x, whose graph passes through the points -148 and 2,6. Show all your work. Now remember, we're going to do this the little bit longer way by hand. Later on, we will have one that we can plug immediately into the calculator and get out the answer, but this one we're going to do by hand. So we start off by plugging each point separately into our exponential function equation. So we're going to have 48 equals a b to the -1, and then 6 equals a b squared. You're going to solve one of these for a. It really doesn't matter which one you do. I'm going to solve the first one here. So I'm going to divide both sides by b to the -1st. So we end up with a equals 48 over b to the -1st. You can keep it like this. Some of you in class felt the need. You didn't like that negative right there right away, so you got rid of it and changed it to be 48b. Either way is perfectly acceptable. Either way will get you the correct answer. It does not matter which form you keep it in. Just for my sake, I'm going to keep it in the 48b here. We're going to plug it in over here to a in our other equation. So we have 6 equals 48b times the b squared that's already there. So we get 6 equals 48b cubed. We want to solve for b. So we're going to divide both sides by 48. So we get 6 divided by 48 means 1/8 equals b cubed. We want to take the cubed root of both sides. The cubed root of 1 is 1, and the cubed root of 8 is 2. So b is 1/2. We now want to find out what a is, so I'm going to take this 1/2 and plug it up here. So we get 48 times 1/2 equals a, and 48 times 1/2 is 24. So 24 equals a. And our last step is to write it in the form of the exponential function. So we get y equals 24 times, and I'm going to put this in parentheses here, 1/2 to the x power. And that would be your answer. Okay, let us do the next one. Give this one a try. Same process. Give it a try, and then come back and see if you have the correct answer. Welcome back. Okay, so we have 9 equals ab squared. Then we have 324 equals ab to the 4th. I'm going to take this first equation and solve it for a. So we're going to divide both sides by b squared. So we get a equals 9 over b squared. Plugging that into the a in our other equation, we're going to get 324 equals 9 over b squared times b to the 4th. So 324 equals 9 over b squared times b to the 4th. The b's cancel out, so we're just left with 9 b squared. Divide both sides by 9, and you get b squared equals 36. So we get b equals 6. Then we're going to take that answer and plug it in here. So we get 9 over 6 squared equals a. So 9 over 36 equals a. So a equals 1/4. And our final step is just to write it as an equation. So we get y equals, our a comes first, so 1/4. And then parentheses, 6 to the x power. Okay, next one, Same concept. You're going to plug it straight up in your calculator, though. Remember, you're going to hit the Stat button. And then Edit. You're going to put your X's go into your L1s. Your Y's go into your L2s. After you've plugged those in, you're going to go back and you're going to hit Stat, Calc, and you want number 0, which is the EXPREG, the exponential regression. And then that's going to come up with your answer, and you will end up with the answer of y equals, because again, I want fractions, I don't want decimals, 1/2 times 1/2 to the x power. So again, that's all calculator work. We want you to be comfortable with your calculator and know how to do that on there. And then our last question of the day, yay, is the following. Rivers and streams carry small particles of sediment downstream. The table shows the diameter x in millimeters of several particles of sediment and the speed y in meters per second of the current needed to carry each particle downstream. So here we have a chart. You're going to put your chart again into your calculator using the same exact process you just did, except a little bit at the end is going to be different. So you put your x's in your L1s, your y's in your L2s, but then at the end here, you're going to hit the button A, which is the power regression. That's the button you want to hit instead of the exponential regression. We want a power function. So that tells us we want to do the power regression. So we plug that in to our calculators. And we get the glorious answer of y equals 0.224 x to the 0.5. So that is the answer to number 12. Number 13 here, use your equation to estimate the speed of a current needed to carry a particle with a diameter of 120 millimeters downstream. So they're giving us 120 millimeters, which is a distance. We see that the diameter here is x, so that means we're going to plug it into x in our equation. So we do y equals 0.224 x, which is 120 to the 0.5 power. And then you plug that all in your glorious little calculator here, and we get y equals 2.45. And this is our y, so that is our speed, so meters per second. And that is your review guide in a nutshell. Hope you've had a wonderful weekend. Good luck on your quiz next week, and have a glorious day.